Okay, well, here we are. We have a wonderful panel to come and share some knowledge. We'll kind of see, we have a good start on the questions, but before we get into that, I know there was some general housekeeping that we wanted to refresh. So first up was the translations. I did my best, but maybe I wasn't as clear as I ought to be, or we have new people joining. And so for the translations to the different languages, when you hit escape out of the full frame window, you should see a sidebar, and in the top right corner of the sidebar, you will find the selection button for the different translations. So if you're having a hard time finding that, go ahead and send another question in and we'll do direct answers. But it should be pretty straightforward. The button is called Interprify. Okay. With that, I know that we have some questions queued up before we facilitate some of our own. So, yes. Martha, take us away.
I wanted to start with the questions from the audience. They're quite specific, and so I'm not sure who would want to answer, but please jump in. And then after that, I have kind of a big thought question, and I'm sure that you have some, Kevin.
Well, I already warned them about a couple. So.
Okay, so let's take the ones from the audience, which are quite specific. I would like to hear definitions of daytime. How many hours at what time of day do we need light with melanopic EDI more than 250 lux?
Okay, well, I'm happy to jump in. As per the recommendations we put forwards, daytime is everything other than the 3 hours before bed. But I think broadly speaking, it's up to people to decide what their, certainly in terms of timing, it's people decide when their own daytime is, right? But broadly speaking, in terms of the recommendations, we're referring to people that are on an approximately normal schedule where their working time aligns with when the sun is up.
I think that 3 hours before bed helps clarify.
It does.
Plus the bedtime.
Yeah.
Except for us in Spain, because we eat so late, so bedtime is But anyhow, second question from the audience. How does the magnitude of spectral differences between typical sources compared to those from the direction of the source, i.e. window or fixture? So source and direction, how do they interplay?
From a light and design perspective, it changes hugely. So we assessed our London office, which had a Cat A checkerboard light solution in there. And then purposefully for our Manchester office, we put the lights over the desks where people are. And there's two reasons. One, we knew that video conferencing at the desk was going to become much more of a thing. So we wanted to light people's faces because that's how you communicate on video conference. But actually it got the light vertically to the eye much more reliably than having a random checkerboard pattern where you place the desk. And for us, it really stresses the Cat A solution in the UK of lights everywhere isn't the answer. You've got to light for people and put the light where it's needed. So it does have a huge impact from a light and design perspective.
Just to follow up on that, has the use of computer screens impacted significantly your research and findings?
It's always been known. In some ways, with screen technology now and with camera technology now, things are actually easier than they used to be. You used to have problems with glare and veiling reflection and things. It's a lot easier now. But this idea, we're all on video conferencing, being sent home, everyone suddenly had to just get used to it. You had no choice. And you're going to come back to the office and carry on doing the same. And so we've got to make sure that face is well lit.
Right, great. Manuel, this one may be for you. It's what about more intense light hitting a small region of the retina versus more uniform with the same irradiance?
I think this is a really good question. So if you were using, for example, measures like lux, what you're effectively doing is you're integrating the light and you're assuming a full integration effectively. And of course, there's infinitely many scenarios that could give rise to the same illuminance or melanopic irradiance. And so in a way, my sort of scientific view would be that using illuminance and irradiance is the first step to estimate about in most scenes, it's probably sufficient to get a sense of the retinal irradiance from that. But you can imagine cases in which you have a tiny point light source that's very bright, that's going to deliver 1,000 lux simply because it's super bright, compared to something like the studio here, which might also deliver 1,000 lux. I think the practical way to address this is to move away a little bit and develop our expertise in measuring spatially dependent light articulation, right? So luminance cameras or even cameras that measure the radiance at a specific pixel is one way of approaching this. And there's now solutions out there commercially to be able to do this. They're quite expensive, but I expect that in the next couple of years probably also it's going to be much more accessible. Because ultimately I think we can't really say if someone tells us, oh, this light exposure or this scenario is 1,000 lux, unless we have additional information about the sources, their angular extent, we don't really know, what the retinal input is going to be. And I would expect that, two sources, one is a tiny light source that's bright and one that's relatively homogeneous, will have different biological effects, even though they're matched.
Right.
So what about the sort of multi-source where it's daylight plus something and how these might work together? I don't know for anybody who's been thinking about that, the sort of layering in of these effects.
Well, I think, Manuel's point is a good one about the spatial distribution, but beyond that, I think in terms of the spectral side, I don't think there's any reason to think that there would be a sort of any particular biological significance of it, what that comes from. But, the spatial distribution is still something that hasn't been worked out, and so obviously, if they're coming from different parts of space, then maybe there might be an effect.
Very good. And I had a specific one for Yvonne before maybe you got to your bigger question.
No, I have one more about
go ahead,
facades. This is for Andrew, and then Ivana, we have some of the big questions for you, the hard ones. But Andrew, someone had a very specific one about facades, so I'm looking at you, but anyone should feel free to answer. They were wondering whether the shading type of facades can affect the non-visual influence of daylight.
It does in many ways. Depending what you're doing with your facade is going to change the light coming in. It'll change the spectrum potentially of the light coming in. If you're going to use wooden louvers, for example, that's going to change the composition of the light coming in. But it changes your view out as well. And so there's multiple layers to all of this. And so, we've really got to be careful with building design and building simulation, which is another section coming up later. You can't just look at a shading system and say this works for controlling the thermals, this works for controlling some glare. There's all of those other aspects to it as well. So I would say yes, it would have an impact.
Great, thank you.
Yeah, so I was curious, Yvonne, for what's coming up on the near-term horizon for this interdisciplinary consortium. What are some of the projects that you're thinking about or that others within the group are thinking about? And are there some specific ways that students, maybe that are not directly involved, should be looking to plug in?
Oh, well, so the PhD students that have started are already in a specific project, obviously, but they are going to be invited to share their insights, and we are going to ask them to make MOOCs to explain their basic discipline to even younger researchers, so to master and bachelor students. So hoping we can actually make that attractive to young students. There will be multiple season schools where we will be inviting others in there, and hopefully also it's not just the students that we're inviting, it's also the mentors and the researchers out there. If you want to share your insights with our team and a broader audience, and please go ahead. Because I think there's not enough time to explain about the 15 different projects. It's spanning a wide range of from daylighting to.
But they can reach out to you, and you'll help
Yes,
sort
yes.
them to
To
the
the
right
light
people.
cap email, yes, please.
Wonderful.
Yeah.
Thank you.
Just one comment about MOOCs. At my school, we did a MOOC several years ago targeted at young people about making architecture. And it was fascinating because we've all found that more than 50% of the viewers already possess another degree. So I think this is really great because not only can you reach out to young people, but many times I'm sure you'll be reaching seasoned professionals who need your information and your point of view. So I'll look forward to that.
Yeah, thanks.
But now my big question, and again, I come from the point of view of city planning, of architecture, of education. I'm not a specialist. I don't do research as my colleague Kevin does. If you had a magic wand and you could wish for one thing, to bring together the very hardcore research, the projects that you were speaking of, and the challenges you spoke of, Ivana. It seems to me that it was great the way you ended to sort of bring us to this questioning of how do we move forward. Now I'm asking you, if you could implement one idea to move forward, to put into practice research, to make it realizable and relevant in the real world, as many of you talked of, what would you do? So, what would you do? Ivana.
Well, yeah. So it's what I really like is we in my group we do both lab-based research and field research, and this is a deliberate choice. And I think we should challenge ourselves to test any idea that we have found in the lab, bring that to the field and test it in real environments, real people. It requires a lot of effort. It requires new tools or better tools than we currently have. It requires that our researchers become a little bit of designers or work with designers, because otherwise it'll be clumsy designs. But I really think that's a really nice way to sort of facilitate this, bring understanding of light in practice for real people in real contexts.
So it sounds to me like you're saying that you would be willing to undertake post-occupancy research and working in collaboration with industry
definitely.
partners. Yeah. Andrew, what would you do?
I would agree. I think the field work is essential, because when you go and talk to a client about an idea, sometimes you'll get a client who gets it straight away. That's great. They're the easy clients. But then you'll get a client who says, well, where's this been done before? I at least need a case study. I don't mind that there aren't 20 buildings or 100 buildings, but I at least need a case study. I don't want to be the guinea pig. But from our own work we did, there's so many variables when you do the field work. You've really got to narrow down each thing you're testing. And we thought, initially, let's just treat it as a working office. Let's take the measurements. It's a working office. We'll ask people to step out of the way while we take the measurements, but everyone's screen's at a different angle. People have got paper down. Someone else has got a black booklet down, you know. So we had to go back on the weekend and clear the place, line all the monitors up and do the measurements. It's really difficult to do field work and come up with something conclusive. Some of the studies I've seen, and one of the reasons we're being very careful about what we've produced is we moved into a new office. Well, there's an uplift to start with. It was new furniture, so there's another uplift. So is the difference really about the lighting? And then if you only change the lighting, you have this impact of you've only changed the lighting. So it's really difficult. But in talking to clients, in trying to get clients to buy into this idea of let's push the boundaries, let's do something different. We know it's the right thing to do. We feel it, and we all know it. What does the standard say? What does the guide say? What am I safe doing? What do my staff, if I do this, could I have my staff complaining? Or if I do this, are they going to be okay? It's really difficult, but I'd like to see, more innovation, more field work, but I recognize it's very difficult.
Yeah, and Manuel, you talked a lot about communication. How would you communicate with developers, for example? How would you get them to listen to you? Because it seems fantastic to start at a young age to help young people become sensitive to the whole discipline, to understanding light and daylight. But there's a whole world out there that exists. So how would you do it?
I mean, I think it's a really fascinating and challenging question that I think we can only kind of approach and then maybe not get to the answer right away. But I think one key thing that I have come to realize is rather than, I think there's multiple ways of making things accessible, scientific results accessible. And I think dumbing down and saying, okay, here's the simple answer is never the right thing. And instead, and I think this is fundamentally quite challenging, I think one of the things that we as scientists may need to learn is how to communicate things like variability, things like error bars, things like, well, here's a mean result, but there's a huge, huge variability that we kind of don't really understand yet. And I think specifically when it comes to the non-visual effects of light, there's now recent research that has shown there's huge individual differences where some people are 60 times more sensitive to evening light than others. And I mean, that's a massive range. As a scientist, more than an order of magnitude, that's big. That's something we need to consider. But then how do we integrate this into a framework where probably what we want to give to people are recommendations where we say, okay, above this light level, you should be good, or you should strive for this light level, where really the underlying biology is so variable that we can't really make these point estimate recommendations. I think, so that's a roundabout way of saying, I think we need to develop tools to communicate variability, to communicate complexity, and to communicate uncertainty. And I actually wonder how, the pandemic, I think, has taught us a lot about talking about uncertainty, talking about predictions, talking about huge error bounds. And I just wonder if that's the direction that we can push forward as well.
Tim, do you think that will happen? I mean, society usually looks to scientists because they give them the truth. But it seems to be that less and less we have truth and we have more and more understanding of these broad variables. How do you see this whole issue of communicating and putting into practice some of your research?
Yeah, well, I mean, I think definitely in terms of what's going to drive the uptake of this, right? Potentially there will be costs involved for companies to implement things like this. So I guess it goes along with comments that we've heard previously. There needs to be more of an understanding of the kind of benefits associated with this. And I was sort of reluctant to say it as a researcher. We always say, oh, well, more research is needed. In this case, I really think, picking up on this idea of field work, it really is actually critical. And basically what we need is integration of detailed information about people's light exposure and longitudinal large-scale studies that kind of draw on task-specific performance measures of productivity, whatever it might be, sick days or, widgets per unit time or whatever it might be. And, even bringing in long-term health data, all of these things. And probably at the level of an individual, the effect might be very small, but when you're looking at the scale of big populations of people, then it really becomes quite significant. And so the more that's realized, I guess the bigger the driver will be towards the uptake of this kind of thing.
I think in the end it's also how much we can raise first interest in our field, right? And in the importance of what we're doing. If people are not very interested, they just want to do good, we have the recommendation, do this and in general you'll do well. But then if you want to know the specifics or go into the interpersonal differences, maybe we need to challenge people also to track a little bit themselves. Self-tracking is a big thing these days. Maybe we can invite offices or companies to do a little bit more tracking and to learn about the way that their company or their people are responding to the light settings, and maybe they can tune it better. So maybe we have to educate the general public in the end to become a little bit of a researcher themselves without saying you're on your own here, right? So I think it's important that we have started now with those recommendations. That's a first guideline that we should follow, but then tweaking around this may involve.
There seems to be so much interest in data analysis. It may be something that will be this wave that sort of can give you some energy for your research, because I think more and more companies, institutions are looking to data. They realize that they have to spend money to gather it. And I think your point, Manuel, we can't give them the answer, but we can give them a range of answers is probably a great way to go.
Yeah. I think the idea of iteration too, coming back to some of your comments, Tim, about you know, the laboratory work begets better field work, begets better laboratory work, and I think, you know, the richness of data sets that are available because of technology and because of, you know, large clients' interest in improving and optimizing their workforce. I think it's really exciting. We're seeing a lot of it. General Services Administration in the United States is collecting a lot more data around circadian exposure profiles. So I think that will wrap our Q&A session up for this Light and Health panel. Thank you so much for sharing your wisdom and your collaboration. I learned a lot, and I'm always excited to share that. So up next at 1300 hours at 1 p.m., we have our next chapter on computational design. So join us again soon.
And at that one, Kevin, we will address how we can democratize access to high-quality daylight simulations and whether new methods, tools, and algorithms can lead to better daylight design. So thank you, panelists, and see you at 1 o'clock.